This is a lesson on ionic bonding. Recall that the periodic table is divided up into metals and nonmetals. And amongst the nonmetals, we have the noble gases. The noble gases are atoms that will not react with anyone, but all the other atoms do react. They form bonds. Metals tend to form cations, and nonmetals form anions. Ions are atoms with a charge, and opposite charges attract. So the positive cations are attracted to the negative anions, and together they make an ionic bond. Ions can have different number charges on them. This influences how they will bond together. So for example, if you have a cation with a 2+ charge and an anion with a 1 negative charge, such as calcium and bromine, you would need 2 bromines to join with 1 calcium. The formula would be CaBr2, meaning there's 1 calcium and 2 bromines, but we don't write the 1 for the calcium when we write the formula. Another example is aluminum and chlorine. Aluminum makes a cation with a 3+ charge, and chlorine makes an anion with a 1 negative charge. How do you think they'll combine? Hint, they want to be neutral. They want to have 0 charge, and in order for that to happen, you would need 3 chlorines and 1 aluminum. And so your formula would be AlCl3, aluminum chloride. Let's do another one. So for example, if you have oxygen with a 2- charge and magnesium cation with a 2+ charge, then for the charges to cancel out, 2- and 2+ cancels out to 0, you would need 1 of each. The formula would be MgO and the name magnesium oxide. Imagine you have aluminum with a 3+ charge and sulfur with a 2 negative charge. Now this gets a little complicated. How do these charges cancel out? Well, if you just work it out, then you will notice that if you have 3 sulfurs with a -2 charge each and 2 aluminums, then you would be able to bind them together. So the formula is Al2S3. Now how do we even know what the charges are for metals and nonmetals? What is this number? We actually can look at the periodic table to find this number. When you see the periodic table, you have the metals and the nonmetals and the noble gases. The noble gases are the only ones already with a 0 charge. That's why they won't combine with anyone. But take a look carefully at this table, and you will see a pattern. Do you notice the pattern? Do you notice where the negative charges are and the positive charges are? In this pattern, every family has atoms that make the same charge. So fluorine will make a -1 charge, and nitrogen will make a -3 charge. And for example, barium would make a 2+ charge. But what about everything in between? The metals in the middle don't follow the same pattern. They are called the transition metals. And let's take a closer look at these transition metals. These metals actually have more than one version of themselves with different charges. So let's give an example. Let's give an example, tin. There's tin 4 and tin 2. And they're both tin, but there's two kinds of tin. So where do we find these charges? They're actually on the list of common ions. So we can look them up. Iron 3 ion, iron 2 ion is listed on this chart, which your teacher can give you. So suppose you wanted to bind bromine with these two twins, irons. Well, they would bind differently. Take a look. Iron 3 with bromine, iron 3 bromide versus iron 2 bromide actually look different. And the way we distinguish them is with these Roman numerals. You need to know your Roman numerals in order to do this exercise. So iron 3 bromide has a formula of FeBr3, but iron 2 bromide has a formula of FeBr2. Another topic is polyatomic ions. This is when many atoms join together to form one big ion, and they behave as one big ion. So for example, if you have 1 sulfur and 4 oxygens and they bind together, they make a polyatomic ion called sulfate. The formula is SO4. And this SO4 can form 2 bonds. So its SO4 negative 2 is its ionic charge. So here is sulfate. And sulfate, SO4 negative 2, wants to bind with calcium. How will they do it? Well, 1 calcium will bind with 1 sulfate. CaSO4. The formula would be CaSO4. If it was tin 4, then how many sulfates will bind to tin 4? Well, you would need 2 sulfates to bind with tin 4. Because remember, the charges need to cancel each other out to make the ionic bond. So the formula would be SnSO4, but remember there's 2 SO4, there's 2 sulfates. So we use brackets with a number 2 on the outside of the bracket to write this. The name would be tin 4 sulfate. We use the full name, we don't use IDE. Let's look at the full list of ions to find another polyatomic ion. If we have a nitrogen with 4 hydrogens. Curiously, these are nonmetals, but when they gather together to form a polyatomic ion, curiously they make a cation, a polyatomic cation. And this polyatomic cation is called ammonium. So let's watch ammonium combine with something. We can combine it with oxygen. So oxygen is -2, makes a -2 anion. And in order to combine with ammonium, you need actually 2 ammoniums. And to write this, let's write the formula of this. NH4, how many of them? Well, there's 2. And there is only 1 oxygen, so we don't write that 1. The name is ammonium oxide.